All right, 10:30. Shall we kick this off?
I'll keep an eye on the chat, and you can take it away.
Yeah. Thank you, André, for helping out. Feel free to interrupt anytime, and this goes for everyone here in the room. So whenever there's any questions, whenever there's something unclear, or if you just feel like you want to chat about whatever, just feel free to unmute yourself or use the chat. Having that said, welcome to Azure SQL Anywhere with Azure Arc. Before we actually get started, thank you very much to the sponsors that made this event happen, because even if it's virtual, it's not at no cost. So thank you for that. I will skip through that. It will be in the recording, so we'll now have my contact details if there's anything unclear after the session. And with this, since we only got 30 minutes, let's get started. Little primer for those of you that do not know what Kubernetes is, because Kubernetes forms the foundation of everything in Azure Arc, so I figured we may have to cover a little ground here at least. So this is something you've all known for quite a while, virtualization. So either you're using VMware or Hyper-V or whichever platform of choice, with the idea being that like 20, 30 years back, whenever we needed some new machines, a new database, whatever, we actually went ahead and bought bare metal and put it into a shelf, and then we realized, well, that doesn't make sense anymore because CPUs and memories and everything is getting so much faster. And then we came up with the idea of virtualization. And by we, of course, I do not mean myself because I know nothing about all this. With the idea being you're running multiple virtual computers with their own operating system and their own network and their own disk and their own CPU and everything on top of an actual physical machine. And the issue with virtualization is that you get a whole lot of redundancy. That means, first of all, you're wasting a lot of disk space because you have, in this example, 3 Windows VMs, but this could also be Linux or whatever. They're all sharing the almost same identical C drive if you want so, but still you're storing the same information 3 times. And also, if there's Windows updates to be applied or anything, this would all happen right in here. So you would have to update 3 different machines individually. And even if you can automate that through Windows Server Update Services or through PowerShell and stuff like that, it is still stuff that needs to be taken care of. So a little later, would say probably 3, 4, 5 years, it came up to the radar of most people here. Something like containers, or called containers, came up. You may have heard of Docker. If not, 2 of our speakers here actually wrote a book on that, so you may want to check that out. The idea of Docker is to abstract that a little more and to share more where possible. So a container, unlike a VM, doesn't bring an operating system, but it's sharing the operating system of the host, and it's using so-called images. So if you're, for example, running 3 different SQL servers, but all using the same version, all using the same image, basically, instead of having 3 different images that you would all need to maintain and patch and store and everything, you would just have 1 single image and push that single image into memory 3 times if you need it 3 times. That means if you want all these 3 images to be upgraded to the next CU, all you do is you update this image and then respin it up into memory. And to make sure that all the databases and all the data behind all that still keeps persisted, data and compute are being isolated or separated in the idea of containers. The issue with containers is that they do not talk to each other very well. So there is something else called Kubernetes, which helps us doing container orchestration. Kubernetes is not the only container orchestrator out there, but probably by far the most well-known, most popular at this point. The idea of Kubernetes is, first of all, you have some kind of physical or virtual hardware, so-called nodes. And this can be 1 VM or 1 physical machine, or it can be multiples like in this picture. So you have all these single nodes, and these nodes are working together. You have 1 master, and then you get a bunch of workers that will just connect to it and basically do the work for it, just like in any other scale-out operation. Within these nodes, you're running so-called pods. So a pod is a collation of containers because you may need multiple different functions, multiple different kinds of containers to deliver a certain application. Like, for example, in big data clusters, which also based on Kubernetes, you would have around 30-ish containers at least, and they're running in at least 15 pods, 15 different pods, because they're separated by what they're doing. And that also means that you can scale by a specific purpose. You'll need a little more of this, need a little more of that, and you would just spin up more of these containers. And again, to make sure that your storage remains attached and at the same time separated, because if one of these nodes goes down, whatever this node was computing before will just be moved to one of the other nodes. Storage is separated. Storage is just attached at runtime to these containers. So from a end user perspective, you wouldn't even see if one of these pods or containers moves across these nodes, and you will still always have access to the very same data. So like I said, the idea of that is you can scale by purpose. So do I need a little more web front end? Well, I would scale up my web tier. Do I need more business logic workers? I could scale those up and down. And same for my data tiers from a generic cluster perspective. So let's keep in mind all this. First of all, it mostly runs on Linux, very lightweight. And the idea is to have rather many small containers that are very specific in what they're doing, and therefore more different kinds of types to allow this scaling by purpose. If you want to learn more about Kubernetes, there is two things that I could recommend you. Either you take a look at this illustrated children's guide to Kubernetes, which is it's an open source PDF. You can just download it, or you can pay them, I think, like €3 or so, and they will actually ship you a printed copy. Or you talk to this guy, Anthony Nocentino. He knows everything you need to know about Kubernetes. And from what I've heard, he's also doing a pre-con on this topic at this year's PaaS Summit. So that might also be something worth looking into. Having laid out the foundation, what is Azure Arc? The idea of Azure Arc is to bring services that used to be Azure exclusive to any cloud, running on any infrastructure, running on any Kubernetes. That's the bridge that Azure Arc is actually, that's the gap that Azure Arc is bridging. So there's multiple different kinds of Arc. There's Arc for Kubernetes, there's Arc for virtual machines. The whole idea at the end is also to have all your inventory in the Azure portal. And from a data platform perspective, that means what we will do is we will deploy Arc-enabled Kubernetes agents, which basically means we enable a so-called data controller on Kubernetes. It's just a service running on Kubernetes, and that will then do the other deployments for us. And then using either the Azure Data CLI or Azure Data Studio, which we'll just be calling the CLI, by the way, they will be talking to the Arc data controller. They will make sure that it becomes visible in the portal, and they will allow us to deploy managed instances in Azure Database for PostgreSQL within this Kubernetes. You could even automate this using Git, for example, which means you could have an automated built-in deployment pipeline for your data instances, which is super cool. And then there's all kinds of monitoring involved as well, like an on-premises, well, shouldn't say on-premises, but on Kubernetes, Kibana and Grafana portal. We're going to take a look at that in a second in the demo. But also the metrics, either pushed or direct back to the portal. That means, again, any cloud, any infrastructure, any Kubernetes, if you're running your own data center on premises with bare metal, if you're running Azure Kubernetes services, if you're running OpenShift on premises or in any other cloud, if you're running a Linux VM on Amazon Web Services and then just as your Kubernetes flavor into that, you can go ahead and deploy an Azure SQL managed instance into that. Not just a SQL server, but a managed instance. That means you would still get the automatic updates. You would still get the managed backups and restores. You would still get the metrics and everything in the portal. And that is something that hasn't been around before, and I think it is super cool. Isn't it super cool, André? Doesn't it at least sound super cool?
Unmute. Yes, it sounds super cool. I needed to find the button really quickly.
So, and because it is so super cool, and demos are so much cooler than just boring slides, let's just do this. So I'm here in Azure Data Studio. Basically, I'm just using a PowerShell notebook here. So this wouldn't have to be Azure Data Studio. But since we will also be connecting to some of these instances later, it kind of makes sense not to just run native PowerShell. So first thing we are going to be doing is I will log into my Kubernetes cluster. What I did before is I've deployed a Kubernetes cluster, and I've also pre-deployed the data controller into that, just for the sake of time, that we actually get some time to play with that. What I can do now is I can run all these different AZ data commands that you see here. So AZ data is basically the tool that we use to talk to our on-prem Kubernetes Arc cluster. So what I can do is I can do AZ data Arc SQL MI list. And this will show me, okay, you can see from the IP address, this is definitely something local. And at this point, I'm running 2 managed instances. I just called them Arc MIO1 and Arc MIO2. They're not high available, so it's just 1 replica each, and they're both ready. If I want to go ahead and deploy a new managed instance, I can just do this. SQL MI create, and all I'm providing here is a name for it. So this will be Arc MIO3. The other thing I could have done is, and we're probably going to skip this one, I could provide more information to that. So there's a bunch of defaults it will always fall back to, but I could provide more details if needed. On my specific cluster, this wouldn't make so much sense. Like, for example, I could say, this is where I want to store my logs. This is where I want to store my data. This is where I want to store my data logs. Hang on, logs, data logs. Data logs would be your database log files from SQL Server, whereas these logs would be the logs from within the container system. Since I'm running on a single node cluster, this is all local storage. I'm not using any external storage or anything. Well, this would basically have the exact same effect. Only difference is this would be a different name. And I'm providing the dev switch back here, which will basically just do the installation as a developer edition, which means I would not get billed for it. But since Arc is currently in public preview, it is free for all anyway. So while this is running, it is reading 2 environment variables, which is using for my username and password. I've set those just up here, so everybody knows my super secret password now. And this usually takes about a minute or 2. And after this minute or 2, I will have a, in this case, 3rd managed instance. There we go. It is ready. If I do this Arc SQL MI list thingy here again, I would see, okay, there is my 3rd instance. That's my IP address. That's my port, and it is ready. And since I am in Azure Data Studio, I could also just refresh my view here or just go straight to the management page of that Arc data controller. And I would see, okay, there's my 3 managed instances. If I had gone ahead and deployed a Postgres instance, this would show up here as well. Besides doing what I did here using the Arc SQL MI create command here, what I could also have done is just be right here in this Azure Data Studio overview. I could say new instance. I want a new managed instance or a Postgre server group. Accept the license agreement. And it will ask me, well, we can just leave that at whatever it is, for username, password, where again, I could set some limits. Kubernetes has the difference between a request and a limit. Request is basically the minimum memory or the minimum cores being provided for that specific instance, and the limit would be the maximum boundary. If I leave this empty, this means they will have no limit for this demo. Shouldn't matter. If I would now go ahead and hit deploy, which I won't, this would just create another notebook and fire it up right away, and this would basically do nothing again but run all these Azure Data Arc SQL MI create and so on statements. If I want to get rid of my instance again, I can just say Azure Data Arc SQL MI delete and whichever the name of it is, and whoops, there we go. And it's gone. If I refresh this, there we go. So that's how easy, once the controller is deployed and deploying the controller is also one single AZ data command, that's how easy you can get a new instance or delete an existing instance. So what I did here already is I connected to one of my a specific managed instances in here. What I want to do is I want to get some data in there. And basically you get two options. Either you have a local file, then you can just copy it using kubectl, or if it's something that is already sitting somewhere on the internet, you could just run a wget and download the file directly in the container. In both ways, let's just do the copy command here. And also the download. Come on. This happens when the internet gets slow within the container, wherever that is, because usually that should be instant. So what this is triggering is it is triggering a download within the SQL container within my MIO1 pod. And what I can do once that has completed while it is running, I could, again, either just run a restore command using kubectl, which is the tool that we're using to actually talk to anything within our Kubernetes environment. So that also means I can use it to connect into any specific container, or, well, while this is happening here, since I've already copied the other one, I could also just use the restore wizard either here in Azure Data Studio or in Management Studio and run the restore from there. So you would say, okay, we want to restore not from a database, but from a backup file. Since this is running on Linux, as you can see, there we go.
Mind if I ask a question in between?
Of course.
It's actually a question from William. He says it is a local install, but it lists as in the region East US. Is that where the Arc connection in Azure is hosted? And is East US the only option during preview?
So what you will do is when you deploy your controller, as long as you want to use the portal connection, which makes perfect sense, because having a managed connection that is not connected to Arc is kind of pointless, to the Azure portal is kind of pointless. What you will do is you will still choose a region, and I chose East US for a couple of reasons during this preview. It is not the only option, but is one of the very few options where it's currently possible, and that amount of regions will be greatly enhanced during public preview up to GA, where I would estimate available in pretty much every region. This is basically just where your metadata will be stored. So this is the region where Azure will basically save all your data about your instances, including metrics. And that is something that you should consider if you're uploading stuff from instances that should not leave a certain region. In my case, it's completely fine. And East US is just, well, in the beginning, East US was the only region where it was actually available. They've enhanced it, but I never thought about changing it. But depending on what kind of metrics and stuff you're uploading, you may want to consider switching, especially when it goes GA, to a region that is suitable for that when it comes to stuff like GDPR and stuff.
Huh. Wouldn't it be cool if this, when you get more services on this Arc, that it just shows up as a region? Where you have region West Europe, North Europe, and Ben's office, and you just use the portal?
So it does basically that. Let me show you that in the portal. Once we get to a point here where this is, has it actually finished downloading? I don't know. Okay, so while this is still running, let's walk through this, and then we'll get back to the portal connection, and then you will actually see it. But basically, every single Arc data controller will have a name. And I just called mine Arc DC Local, and I would also have an Arc DC AKS and an Arc DC AWS and so on. But yours could be Arc Data Center in whichever city you have it, or Arc Data Center André, or Arc Data Center Ben. And if you go to the Azure portal, then it would show the Arc data controller behind it. So it would show this is actually physically running in the André data center, but still the metadata that is synced back to to the Azure portal, that needs to be stored in Azure to make it available in the portal, and that needs to be in an official Azure region.
Pretty cool.
Yes. So
everything will be one big Kubernetes cluster later, right?
One Kubernetes cluster to rule them all. So to get this connection to the Azure portal, there's a couple of steps that need to be run. So first of all, you need a service principal, which is just an object in Azure, which basically gives you a user, which is not a regular user, if you want so you can automatically talk to the portal in the background. You need to give this thing a couple of rights, like monitoring metrics publisher, which means that this service principal will actually have the option to upload logs and metrics. We will need a log analytics workspace, and then you get back a couple of keys. And then basically what you just do is you put all those into environment variables. How are we doing here? Cool. I will just go ahead and set these environment variables. And then at this point, there is only the indirect mode, which means you basically go ahead and you export the log files from every single instance that you have. So you see it takes CPU usage and memory usage and everything from our, well, 2 remaining because we deleted 03, and puts that into 2 different JSON files. And then you upload it. What I could have done is I could have had that in the same step, or what you would usually do, obviously, is basically just put that into kind of a batch file or a PowerShell file, whatever, and then just schedule this to run every minute, every 5 minutes, every hour, depending on how often you want your metrics to be uploaded to the portal. One thing that has been announced but is not available in preview yet would be direct connect mode. And direct connect mode would mean that your data controller is automatically and instantly talking back to your to the Azure portal without you doing any interaction in between. So let's just do this. I click here on my Arc MIO1 and I just say open an Azure portal. And this is so cool. So there you see my location for the metadata, that's East US. But my Arc data controller is my Arc DC local. And like I said, this could also be the Arc André. It's also showing my internal IP address here, even though it says external endpoint. So this is the endpoint of that thingy that would be reachable if you're in the right subnet. And I could now ahead and go and say, well, what are my metrics? I want a SQL Server metrics. I want CPU usage, and boom, this is where I just did this super CPU incentive and intense restore of AdventureWorks. And I could go ahead and say, okay, so how did my memory usage change and stuff? I could do the same thing for log files and everything. This will also show as am I, and if I could. So they will also show up here as Azure SQL Managed Instance, Azure Arc, if you search for these resources. So despite of these resources not being actually in Arc, Arc only holds the metadata, and Arc only holds the metadata because I synced it. I can use them from the portal just like any other Azure resource. I could also go ahead back here, take a look at my resource group, and we would see, whoa, there's my data controller and there's my 2 instances, both showing up as just regular resources here in Azure. The other 2 things that come with it, like I said, is the 2 internal dashboards, Kibana for all the log files and Grafana, which I think is more interesting. And for the, I'm going to take a look at that. Gianluca has actually got a great session on that. Grafana and Kibana are both open source tools for monitoring all kinds of stuff, and they've also already been implemented in big data clusters, and they're also part of Arc. This gives me one central looking glass into all of my Arc estate here within this specific Arc installation. So if I would have multiple Arc controllers, they would not show up here because they would be in their own namespace. But this gives me, especially if not everyone might have access to the Azure portal. Plus, this just has a couple of more information that may not even end up in the Azure portal because the Azure portal doesn't have a meaningful endpoint for that. I could just switch from one instance to the other. I could show my host metrics as well. So how long has this cluster been up and running? What's my memory usage and so on. And so on and so on. Same thing would be available for Postgres. We won't see anything here because there is no Postgres deployment in this specific Arc installation that I've done here. But the Postgres deployment would be the exact same thing like the MI deployment, except that it would not do a SQL MI deployment, but a Postgres deployment. But it would just say AZ data, Arc, Postgres, create, and provide a couple of more information to that as well. And this is how easy you can get as many managed instances on-prem or in any cloud as you would want or would need. At the same time, having the advantage of not just running a SQL Server on Linux on-prem or wherever, but having that link back to the Azure portal. So that means in the Azure portal, you would see every single SQL instance that you're running, no matter where it is. You would see all the metrics for it. You would have centralized billing going forward. Billing is also not implemented yet in the preview. Like I said in the preview, it's free for everyone. But that's kind of the idea, having it all in one single piece. So that also means all of those that were not able to use something like managed instance before because they're running a multi-cloud strategy, for example, that is the answer to it. And I may have said that before, but I think it's pretty cool. This is again where you unmute yourself, André, and say, yes, it's
found it.
Cool.
I actually have a button on my Stream Deck that I can just hit and it will unmute. But then, yes, it is really cool.
So, a part of the fact that we all agree that it is pretty cool. Any questions from either you or the audience?
Ooh.
Is it planned to move other services to this Arc, like data, stuff like this?
There is no public roadmap for it, but my expectation would be that quite a bunch of Azure exclusive services would end up using that technology, because that basically, I mean, just from a pure sales perspective, there are a lot of customers that cannot go to the cloud, or that say we were not going to do anything that is Azure exclusive because we don't want that infrastructure vendor lock-in, or there is just no Azure data center in the right region, or these. So I would expect quite a bunch of different services to end up there. So from a data perspective, like I said, at this point, it's Postgres and SQL MI. Going forward, I would expect more and more to show up in there.
If you have questions, just unmute yourself. It's totally okay. You don't have to type in the window thingy.
Or you can unmute yourself and then start typing so we can hear you typing.
So is there a way if you have a third-party application that is really hard to move into an Azure data center because it's a monolith, is there a way to unlock this monolith through this thing to work together with Microsoft and use some specific APIs, or is that a step too far still?
At this point, it's a step too far. I have no idea if at some point they would go ahead and kind of open source the Arc API. I mean, this wouldn't even be data services exclusive, but this would be, or data services specific, but this would be general Arc, because I mean, in theory, you could have all kinds of services from Azure end up with an Arc connection. I'm not even sure if that's something they're looking at this point. Oh, and before I forget the most important thing, shameless self-plug, there may or may not be a book coming up on that specific topic.
This is where everybody unmutes and says, oh.
Ooh. Yeah, that's kind of what I was expecting, but well, I mean, it is what it is, I guess.
And it's with Anthony Nocentino, that famous guy.
Mm-hmm. I'm not going to comment on that since it's all going to end up in the recording. Anthony, I love you in case you're watching. But yeah, it is with Anthony Nocentino. I mean, in the end, it is all based on Kubernetes. And like I said, he knows everything about Kubernetes. So it kind of makes sense to team up on this.
So is there an overlap with the big data cluster? Will that merge into this? How does that, because that's similar, but not the same, right?
That is a question that I've also been wondering myself. And I mean, big data cluster is kind of still more focusing on even though it's technological also on Kubernetes, it's more focusing on the on-prem part.
Mm-hmm.
But I could totally see going forward to have Arc-enabled big data clusters, for example, where you basically, again, just upload your metrics and stuff, and again, potentially make use of joint billing and stuff, because I would expect, well, like I said, billing has not been published, and they haven't even talked a lot about billing yet, but I kind of would expect that I would be able to basically just pay through my Azure Arc managed instance, even though it's running on-prem through my Azure subscription. And that might also be something that could work with big data cluster. But then again, big data clusters at this point is just part of the SQL 2019 offering. So it's a perpetual license, not a pay-as-you-go license. So there may be one or two questions in between that need to be solved by Microsoft first. But yeah, I mean, from the general idea, I mean, like I said, big data cluster is also using Grafana and Kibana. So most of the interfaces probably are already there to actually enable all that metrics upload and inventory on the portal.
Yeah, I can definitely see the overlap where you just, of course it happens on-prem, but you manage it from the cloud or something. So you have all the metadata centrally.
Yep. Again, especially for customers that use big data clusters as an intermediate step because they need a data lake right now and are not ready for the cloud just yet. Or even if it's not big data clusters, I want to start using managed instance, but I can't go to the cloud just yet for connectivity reasons, for example. Those are all perfect use cases where you might start with that with Arc Data Services now, and then at some point just migrate it towards the Azure cloud. Cool. So if there's no more questions, thank you very much, everyone, for attending. Thank you very much, André, for your help. Thank you very much, Eric, for organizing, since we've got you here as well. And I guess
for sharing.
Oh, my pleasure. And I guess I see you all in a couple more sessions over the course of the day, and then of course at 4:15 in the coming together session, where we're all going to have that virtual beer, or actual beer virtually, or however.